So we are starting with the last one there. I'm trying to launch my Liveboard app here. And I'm gonna have serious problems when it comes to admitting others, because now it is this device that is what hosting the meeting. Let me see. You see, there are people who want to join. So we are using the last question paper, ne? The last paper that was sent to you. Am I audible?
Yes, you are.
Okay. So I hope you all have that question paper. What is written on top of that question paper, the last one that I've just sent to your groups? What is written on top?
Draw pets, demand curve for sugar.
You are with me. Thank you. That is exactly the paper I'm referring to. So I'm not gonna present the paper. I'm only gonna present the whiteboard. But I don't know how I'm going to do this. I think I'm gonna end up presenting my entire screen. But of course, let me do it.
Oh. Okay. Okay, thank you.
Let's mute the mic.
Thank you.
Whew. But you guys have the question paper, right?
Yes.
How am I going to do this now? Okay. Let me try to rotate. So the question says, we are looking at question 2, that one of 30 marks. Explain the meaning of the law of diminishing marginal returns. Use a diagram to illustrate your answer. I'm not going to explain that. It's there in the notes. Diminishing marginal return is one of the production functions. I told you about the diminishing marginal returns, constant marginal returns, and increasing marginal returns. So when you use the diagram, remember I told you that they might ask you to differentiate between those 3 production functions using your own values. But in this case, they have specified that, oh, here they are talking about the law of diminishing marginal returns. It's also there in the notes. Please make sure that you check the law of diminishing marginal return. The graph is also there, which supports the law of diminishing marginal returns, meaning that the returns declines as more of outputs are yield, I mean to say are produced or are yielded. So we go to question 2.2. It's the one I am actually interested on calculating with, I mean to say with you. Consider the production function for mangoes in Zanen farm. Y equals x plus 8x to the power 2 minus 0.2 x cubed, where py is 5, which is the price of mangoes. So the question says, question A, derive the marginal value product, which is the VMP or the value of marginal product, and the AVP equations of mangoes in Tsanen farm. So you know the formula for deriving those. They need the what? What do they want? Are you guys able to see my screen?
Yes.
Okay.
Yes.
What did they say we must calculate? Remember, I only wrote the function down, the production function. They said we calculate the VMP and what?
And the AVP.
And the AVP. So we are deriving the VMP. What is the formula for deriving the VMP?
MP multiplied by PY.
Multiplied by PY, right? And then are we given the MPP from the function? From the function, are we given the
we are given?
We are
No,
not
just
given
given a
the MPP,
function.
right?
No.
We must derive it. And then APP
Yeah.
are going to calculate, I mean to say AVP is what? Is APP multiplied by the price of Y. I taught you yesterday how to derive MPP and how to also derive the APP. So we'll start by finding the MPP and the APP. Then from there, we are gonna derive the VMP and the AVP. So let's start with the MPP. We are given the function Y equals X plus 8x squared minus 0.2x cubed. So MPP is dy dx, which is equal to, we differentiate this function, and then we are going to divide it by y. What is the derivative of x?
It's 1.
It's 1 plus the derivative of 8x squared.
16x.
16x minus the derivative of negative 0.2, the derivative of 0.2x to the power 3.
Negative 0.6
X squared, right? So we divide it by 1, which will still give us the same outcome. Do you all understand how to calculate, how to derive the MPP? Did you all understand?
Yes, ma'am. Yes.
Okay, thank you. This is your MPP. Now let's derive, you'll get a mark for deriving the MPP. Let's derive the APP is equal to Y over X. So your Y is what? Is X plus 8x to the power 2 minus 0.2x cubed. So we divide it by x, meaning that everything here, every term. So this term here, no, this is obscuring my view. So this x is divided by this x. This 8x squared is also divided by x. We can separate them. This one is also divided by x. So you know the loss of exponents. If the bases are the same, you write one base, you subtract the exponents, right? So even here, you write one base, which will be 8x, and then you subtract the exponents. 2 minus 1, you will get 1. So you end up having 8x. Then you come here, you do the same, negative 0.2x, then you write only 1x, you subtract 3 exponents, 3 minus 1. Do you understand?
Yes.
So this x will divide this x, you will get what? 1 plus 8x squared divided by x, meaning that 1x will fall. So according to the laws of exponents, remember, you will write 8x, 1x, and then exponent, you subtract the exponent, this exponent 1 here, you subtract 1, so you will end up having 8x. So it's 8x minus 0.2, you write 1x, and then you subtract the exponent. 3 minus 1 is 2. So this will be your APP. Do you all follow?
Yes.
So we can calculate the AVP. We take what? We take the PY, we multiply by the APP equals, what is the price of Y? They said it's 5, right? You multiply the whole function of APP. Then from there you get the answer. 5 times 1 is 5 plus 5 times 8. What is 5 times 8? Is it 40?
It's 40.
40x,
Yes.
yes, minus 5 times negative 0.2. 5 times 0.2?
It's 1.
1.
Yes, it's
And then
1.
x squared. So this will be the formula for calculating AVP. So you have derived AVP. Do you guys follow?
Yes.
Okay. So remember, we did not derive the VMP. VMP equal to PY MPP. You have PY, which is 5. You also have your MPP, which is this one. So 1 plus 16x minus 0.6x, also, I mean, say squared. And then 5 times 5 is 5 plus 5 times 16. You will get the answer. I don't know if it's 80 or what. What is the answer?
It's 80x.
80x. Then 5 times 0.6.
It's 3.
3, and then x squared. So this will be your VMP. Do you see that once you have the formula and you know how to work around each component of the formula, you'll be able to get the answers. Do you see that it's easy? So let's check another question. Another question says, at what level of X do the TPP of mango reaches its, okay? At what levels of X does the TPP of mangoes reach its maximum? 5 max. What does it mean? What are you supposed to do with this kind of a question?
TPP reach It's maximum when MPP is equals to 0, and then we solve for X.
Good. So you are going to write that statement. If you don't write the statement, you will not get the max. So you will say TPP reaches its maximum. You can even state the stage, right? Maximum in stage 2 or towards the end of stage 2 when or where MPP is equal to 0, right? Then you check your MPP, you equate it to 0. Your MPP is 1 plus, let me write it down, 1 plus 16x minus 0.6x squared. So your MPP is 1 plus 16x minus 0.6x squared, you equate it to 0. But you know that in this case, you cannot solve when you have a problem like this one. So you have to make sure that you arrange your equation in order, right? So you start with the one with the bigger exponent, followed by the one with the second bigger exponent, and you end up with the one with the smaller exponent. So it means that we have negative 0.6x to the power 2 plus 16x plus 1 equals 0. But then you cannot, mathematically, you cannot solve this equation when the coefficient of x squared is negative, right? To simplify things, you have to multiply the whole equation by negative. So you will end up having negative times negative being positive, plus, it's not plus, it's minus. It will be minus because this minus here will multiply the minus here, you get the negative.
What if I divide by negative?
Yes, 16x minus 1 equals 0. Then you have solved the problem. Are we together?
Tumelo,
Yes.
Yes.
is it fine if I can divide by negative?
By
if
negative.
I can also divide, yes.
If you can divide each term by -1.
Yes.
Yes, if that is the question, it's still correct. Because when you divide each term by -1, you will end up getting the same outcomes here.
Okay.
Yes, thank you. So that will be the answer. So is this a quadratic equation or a cubic function or a linear function?
Quadratic.
It's a quadratic.
Why quadratic function?
Because we can factorize a decimal.
Really? What characterizes a quadratic function? How does a quadratic function differ? Differs from, yes?
Squared.
Because of x squared.
It's because of to the power 2. So if your equation has the highest exponent being 1, it means that it is linear. Just like the demand function, QD equals A minus B, let me say BX, for example. So it's linear because the highest exponent here is what? Is 1. So it's linear. But once the highest exponent is 2, it's quadratic. Once the highest exponent is 3, it's cubic, just like that. So the reason we are saying this is a quadratic function is because its highest exponent is 2. So since you have identified or you have noticed that this is a quadratic function, you can then use what? A quadratic formula, right? to calculate the value of x. So x, according to the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a, right? So this equation of yours is written in the form of ax squared minus bx minus c equals 0. Do you agree?
Yes.
Then what is the value of a?
0.6.
The value of b?
60.
You take it with its sign actually. Let's say it's plus plus. So we are going to take it with its sign is negative, right?
Yes.
And then the value of c?
-1.
-1. So you are going to substitute them here. So you said b is what? B is -16. So -16, you put it in brackets. The square root of -16, I mean to say, you square it in brackets. If you don't put it in brackets here, you will have serious problems. Plus or minus here, don't forget. Minus 4, the value of a, we got 0.6, right? 0.6 times the value of c is -1. And then you divide by 2 multiplied by 0.6. And then what is the answer? What are the answers?
26,73.
3 and -0.06.
Therefore, x equals 26.73 or what? Negative 0?
Negative 0.06.
Negative 0.06. So this is the output, right? You have to conclude. So this is what we are looking for. This one, we cannot consider it. So we will not say, oh, this was negative. So we say, oh, x is not equal to that because the output can never be negative, or the input can never be negative. You can never use an input of negative. So they are always positive. Are we together? So we are going to consider the one that is positive. So we will say, you conclude, therefore, TPP reaches its maximum when the value of x is approximately 27 units of input. The sign approximately is very important here because 26.73 is not 27, but we have rounded it off to the next whole number integer. That is why we are approximating it. Do you get it?
Yes.
Okay.
Yes.
Thank you. And then let's check another question. At what level of x does stage 2 begin or stage 1 end? Yes. At what level of x does stage 2 begin or stage 1 end for the production of mangoes? What do they mean? Where does stage 1 end and stage 2 begin?
Stage 1 and when MPP equals to APP.
Good, that is true. Stage 1 ends at a point where APP reaches its maximum, and that is a point where MPP and APP are equal. So hopefully you still remember that graph. So this is how they said. If you don't know your story, you will not get this right. So you will write stage 1 or stage 1 ends or stage 2 begins at a point where APP reaches its maximum and APP is equal to MPP. So you write that statement and then you equate the MPP and the APP. We have the MPP and the APP. So Your MPP is 1 plus 16x. This is MPP to avoid 1 plus 8x minus 0.2x squared. Okay. So we are going to substitute the APP and the APP. Our APP is 1. We got 1 plus 8x minus 0.2x squared. And then the APP we got, what did we get for MPP? 1 plus 16x
minus 0.6
minus 0.6x squared, right? And then you can solve this equation. You decide what you want to do, right? You can either take this whole equation to the left-hand side, or you take this whole equation to the right-hand side. You do what you want, or you just take these ones, this side, these ones with x, you take them this side, or these ones you take them that. It does not matter, as long as at the end you will get the same answer, right? So let's say 1 plus 8x minus 0.2x squared. We are taking that whole equation to this side. We'll have minus 1 and then minus 16x minus plus 0.6x squared equals 0. So what is 1 and negative 1 will give us 0, right? And then positive 8x with negative 16x will get negative 8x. Negative 0.2, we are left with less than 10 minutes. Negative 0.2x squared, you add like 10s together, plus 0.6x squared, you will get plus 0.4. Is it 0.4x squared, right?
Yes.
Equals 0. So you can take this one, or should we take the common factor here? Do we have a common factor?
Yes.
Yes.
What?
X.
We can factor out x, and then we remain with negative 8 plus 0.4 x equals 0. Then I think you can take it from there. X equals 0, right? Or what did we have? We had negative, I need to say we had x into negative 8 plus 0.4x, and then we equated it to 0. So it means that there are two values of x. So if x equals 0, or negative 8 plus 0.4x equals 0, and then 0.4x equals, you take this 8 to that other side, you will have positive 8. Therefore, you divide both sides by 0.4, 0.4.
Which is equals to 20.
Therefore, x equals 20. So it means that we are not going to consider this one of 0. We take this one of 20. And then you will conclude. Therefore, stage 2 begins at, or stage 1 ends at a point where the input level is 20. Are we together? So it's just you applying the mathematical principles here. If you forgot the mathematical principles, there's no way you can get this question right. Are we together?
Yes.
Others, are you still with us?
Yes.
Okay.
Yes.
The last question, find and interpret the elasticity of mango when x equals 1. They are telling you that x equals 1. They gave you the value of x. So you are supposed to calculate elasticity of production and interpret it. What is the formula for calculating elasticity of production?
EP over MP divided by
MPP over APP.
Right? Yes. So you have the MPP function. The MPP function we got 1 plus 16x minus 0.6x squared. Is it correct? Yes. And then over 1 plus 8x minus 0.2x squared. They gave you the value of x. They said x is what? Is 1, right? So you substitute 1 here when you see x. 1 plus 16 multiplied by 1 minus 0.6 multiplied by 1 squared over 1 plus 8 into 1 minus 0.2 into 1 squared. And then you give us the answer. The answer is do you follow these things or you are lost?
we follow.
Okay, thank you. So what did you get?
1.86.
Whatever the value you got, right? So what is the interpretation? Isn't it?
It is stage 1, which is
Yes,
greater than,
elasticity is greater than 1.
MPP greater than.
which means MPP is greater than APP.
You are ready. So it in stage 1 of neoclassical production, you will tell them that it's stage 1. The farmer is operating in stage 1 of neoclassical production because the EP of 1.86 is greater than 1. And that implies that the MPP is greater than the APP. Are we together?
The farmer is what to me?
The farmer is operating in stage 1 of neoclassical production function because the EP that we got of 1.86 is greater than 1. The EP that we got of 1.86 is greater than 1, which means that the MPP is greater than the APP. Did you get it?
Yes.
Yes.
Okay, thank you. Then you are ready for the exam. Let's see what else from this question. List and explain 3 factors. So we are done. 30 marks. You see, you already have 30 marks in the exam, or 20 rather, because we did not do that one, but you know where to find it. Let's look at this question. Will you fail to calculate this one? Let's look at 3.1. Derive the MPP and the average physical product. Will you fail to derive the MPP and the APP?
No.
No. At what level of X does APP reaches its maximum? What do they mean?
APP reach its maximum when MPP equals to APP.
Yes, in stage
1.
In stage 1. So it means that you will say APP reaches its maximum in stage 1, where it is equal to MPP. So you will write that condition and then you say MPP equals APP, and then you equate the MPP that you derived in question A and also APP. You equate them just like we did now, and then you will get the value of X. Are we together?
Yes.
Yes. So I think you can also, yes. I think you can also calculate the elasticity. Will you fail to calculate elasticity when you are given the value of X? You have calculated you have derived MPP and also APP. You are given the value of X. You just write the formula for calculating elasticity. You substitute MPP and APP, and then you also substitute the value of X, and then you get the answer after that you interpret. Is it difficult? Hmm? Do you think you will fail to calculate elasticity?
No.
You won't.
No.
Thank you. So let's see. This is another function. We are left with less than 1 minute. Let's look at question 4. They have repeated that question again on 4.1. So it means that it's important. Make sure that you go and check the law of diminishing marginal return. Know also how to use the diagram to illustrate the answer. 4.2. Derive. Is this the same equation we were working with? Y equals x plus 8x squared. Let me see. It's the same, right? Okay.
Yes, it's the same.
And then, so we are supposed to come to this one. I don't know. Should I release you and then you will work on those, or you should rejoin so that you can complete the table? Because I don't think question 2 will give you problems because it's something we were doing not so long.
Let's
So you are given the function, you should derive MPP and APP, and then at one level of X, does APP reaches its maximum? You know the stage and whatever. Find and interpret elasticity. I don't know. I don't think you'll fail to calculate this one if you have MPP and APP. So you are going to rejoin for 15 minutes. We'll be working on that table.